Okay, Passerians, welcome to the video. We're solving a multiple equation angle today. And you, if you're in my class, probably already know how to do this. So we're going to go a little fast, but you can always slow down the video if you need to. Just go down to that gear and change it to 0.5 speed, okay? But we're going to fly because we already know we can subtract 3 and divide by 3. And once we do that, we clearly have tangent of x over 2 equals negative 1. And that's cool because basically we want to know what theta would be, theta, which actually is x over 2, right? Well, theta would actually equal whatever angle makes tangent negative 1. Well, since all students take calculus and tangent's coming out negative, we're not in this quadrant or this quadrant. And tangent is 1 at a reference angle of 45 degrees, okay? If you're trying to relearn how to do this equation from scratch, this is not the video to watch. We're just kind of brushing over it as we get into it. So one answer is going to be this, because this is a pi over 4 angle, and this is a pi over 4 angle. And what we're going to say is that we know the answer is basically pi over 4. Whoops. It's not pi over 4, though, is it? It's a derivative of pi over 4. It's kind of like a pi over 4. I think I want this one. So basically, it's pi over 4, but it's not pi over 4. It's 3 pi over 4, right? And then how far would I have to go to take this right here, this branch, and go all the way around to here? That would be adding pi, 180 degrees. And then all the way back here, that'd be adding pi, 180 degrees. And then all the way back here, I'd be adding pi. So I have to add pi n times. So that's what we're looking for. Now, I shouldn't have put that in the box because that's not the final answer. What we really need to do is we need to consider. So let's just erase that just for the lack of confusion here. We don't want to confuse people. What we need to do is do what? We have to multiply both sides by 2 because we're not looking for theta, we're looking for x. So if we multiply both sides by 2, we get 6 pi over 4 plus 2 pi n, right? Because we're multiplying by 2. So that's good. Multiplied both sides by 2, and now we have x equals 3 pi over 2 plus 2 pi n. Okay? And that's pretty much what we're looking for. So you can feel free to pause the video and try this next problem down here if needed. I'm just going to check my answer. So feel free to pause the video and try this if you like. But I just want to verify that that is good. 3 pi over 2 plus 2 pi n. Now, those of you in class, we're just going to skip over it, right? Isn't that great? So we're just going to keep on trucking. So feel free to pause and go back if you need to. This is using inverse functions. In class 2025, we did talk a little bit about this. We used our scientific calculators to solve this. I see an equation here with a secant squared and a tangent in it. And I know that one of those has got to go because they're mixed. And ideally, you don't really want them mixed. Not really. So secant squared is easiest to get rid of. The way that I find secant squared is I take sine squared plus cosine squared equals 1. And I divide everything by cosine squared because 1 over cosine squared is secant squared. So this is going to be tangent squared of x plus 1. Now, a lot of you memorized that already, so we'll just replace this with tangent squared of x plus 1. Of x plus 1. Minus the 2 tangent of x is still there. Equals 4 is still there. This is the equation we're trying to solve. It looks like if we took the 4 over, set it to 0, we could probably factor it. So I think it's going to be tangent squared of x minus 2 tangent of x. And if we subtract 4 from both sides, we'll get negative 3 equals 0. And we then just need to know, and watch out because that minus sign seems to be missing. We just need to know what this will factor into. Now remember, just a quick little reminder, what you're doing is you're basically thinking of this as x squared. You're thinking of this as minus 2x, right? And you're thinking of this as minus 3. So this is kind of what you're factoring. The purple would factor into tangent of x, tangent of x, tangent of x, tangent of x, and then 3 and 1, and then negative 3 and positive 1. So that would be how that would go. So now we just need to focus on setting the factors to 0 and solving them. If we FOIL that purple thing out, we'll get that first purple line, the middle one there, the top one, I guess. So we have two equations. We have tangent of x equals 3, and we have tangent of x equals negative 1. Is there one of those that we could solve? Could we solve either of them? Can we solve neither of them? What are our thoughts? We could solve which one? Nice. We could solve that. All students take calculus. Did we do it earlier? Oh, nice, cool. So 3 pi over 4, very good. Did it say just solve, or did it give you like an interval, or what did it say? I see. So I guess I would add my thing, right? So add pi n. Okay, why not, Okay, so that was comfortable. We were okay with that. Now the next thing is, how do we get the tangent out of here? Now this is something in this class we'll do many times with inverse functions. We get rid of tangent with arctangent. On your calculator, it looks like this. Tangent to the negative 1. We are arctanning both sides, okay? That cancels, and that gives us x equals arctan, exact same thing as tan to the negative 1, of 3. Simply type that into a scientific calculator in radians, right, and you should be okay. So I'm going to type in tangent to the negative 1 of 3. 1.249 is correct. So in this case, x would equal 1.249. X equals 1.249. Now, we don't know exactly where that is on the unit circle, but what would we have to add to that to get around? What's the period of the tangent function? Like, what logically do you think follows? Yeah? Yeah, pi n. I think it's going to be pi n. Right? Pi n. Okay. Let's double check. It's always good to make sure that we're right with these things. So using inverse functions. Oh, they actually just wrote it as arctan of 3. But you could use a calculator if you want. So what they did was they actually wrote this. They wrote x equals arctan 3. I wouldn't do it that way, but plus pi n. So, or. You could do that if you didn't have a calculator. That would be okay. So just be aware it could happen. Okay. We're ready to go to one more, which is the last one. But do you need to try that one, class? Or rather get on with it and then do your homework later? Okay. Let's just press on then. We're going to press on, everybody. The decision has been made. Okay, I did this in my other class, and it didn't come out nice, so I just decided that it's find a solution of this, okay? I decided it's find a solution of this because it was a little time-consuming otherwise. We'll talk about it later, but I just want to get the basics down for you. So you see how I rewrote this? You see how I wrote this kind of like that? Well, if we were going to use the quadratic formula on that, we would do negative b plus or minus the square root of b squared minus 4ac, right? And that's this. And that's all over 2a, okay? You guys know that song, right? It's negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, good. Oh, wow. Adele does it, I think. Okay. You probably did. The quadratic formula is negative b plus or minus the square root b squared minus 4ac all over 2a. Okay. Oh, wow, okay. Well, very musical class we have here. As we know, since 17 people are going to be out for band in a couple days. Okay, so I'm going to solve this. I got x equals 3 plus or minus the square root of, that's 8 and 9, so that's 17 all over 2a, but I forgot that a is just 1, so just all over 2. And that's pretty much what I need. I'm going to write it as two different things, and I know that I'm not really solving this for x, am I? I'm actually solving this for sine of x equals, and sine of x equals. Well, sine of x, which is x, right, must equal 3 plus the square root of 17 over 2. 3 plus the square root of 17 over 2. A plus or minus is just a lazy way of writing this twice. So we really should write it twice. You know what I'm saying? And 3 minus the square root of 17 all over 2. Cool. Okay, what are our thoughts on the top and on the bottom? See anything? What are your thoughts here? This is probably going to be a calculator situation, wouldn't you think? Yeah, so that's probably why you learned that calculator thing 3 minutes ago. So I would say you need to arc sine that, and it should be x. So arc sine of that should be x. So that's 3 plus square root of 17 all over 2. What was that? AKA x equals. Yeah, it's going to take a little bit of time. Yep, it's going to take a minute. Oh, for the top one or the bottom one?
I think it's because I sent it a link to something yesterday.
3 plus the square root. I'm typing this into a scientific calculator. I got that, and I'm dividing that by 2, and it's 3.56. Ooh, I don't like it. What's the problem, you think? Any ideas? Ah, yes. No solution for that one. I thought this was going to be the no solution, but I was wrong. So this one probably will not give you an error. So this is actually not defined, so I'm going to just scribble that out. Okay, how about the next one? Let's do the negative one. I thought the positive one was going to come out. Okay, that's bigger than 1, so it doesn't work. The top is like 3 plus 4-ish, so it's like 5 over 2. 5 over 2 is bigger than 1. You can't take the arc sine of it. This one's going to be the one that we want, which is equal to, I guess if you want to kind of have an idea, let's see, what is that? 3 minus second square root 17. Divide that guy by 2. So I thought this one was going to be the one, but this is the one. 561. 562. Okay. Squiggly equals? What do you think squiggly equals? Yeah. And so now let's arc sine that. Let's arc sine that disaster. Not the answer, sorry. I'm not at the answer yet. And then you just type it all. That's fine. That's best. I'm going to type it all back in anyways. But I just wanted to show you that it was smaller than, or bigger than -1, I guess, technically. Yeah. Okay. And if you have a scientific calculator, it's pretty obnoxious to type it in, by the way. So if you didn't know, it's the worst. So 3 minus second square root 17. And you probably would have a scientific calculator, because if you had a graphing calculator, we wouldn't even do this. You just graph the guy. You know what I mean? So just be aware of the nuances and annoyances of the scientific calculator. Did we get negative 0.596? Nice. And as you can see, I just said let's find one solution of that, okay? Because I didn't feel like going into how this is a quadratic, and you can't exactly add 2 pi to it in this situation. I mean, I guess maybe you could add 2 pi to that, but it was kind of a nightmare. So, nah, I'm not about it. So I think this would be a good time for you to pause the video and try to give this problem a shot. It looks pretty awesome. And then just to summarize all the stuff we talked about, feel free to pause at this moment. We want to know how to use regular standard algebra techniques. You know, like solving equations, right? You add and subtract from both sides. You square root both sides. You square both sides. You use the quadratic formula, right? So generally, you'll see examples 1 to 3 where they're doing that generally in a basic type. Quadratic type is what we just kind of talked about. And by the way, those are examples 4 to 6, which we just did example maybe 5. And then there's this multiple angle thing. That's what we did that's basically where we have like 2x, right? We have like cosine of 2x equals 1. So we have to have 2x equals, and then we find the answer, and then we divide by 2. So these are all the things that we've been kind of doing. And then lastly, we can use inverse trig functions. This is what we did yesterday and today, where we used our calculator and the arctan or the arcsine. And again, those are examples 9 to 11. And that's pretty much everything that we've done to solve these equations. And everything that we've done to solve the equations is like built off of simplifying and verifying and all that stuff, which is the first couple sections. So I hope it went great for you. Pause the video, try this, and in just a minute, I'm going to put up the answer. So spoiler alert, pause the video now. All right, here comes the answer. Very exciting. Drum roll, please, okay? All right, so we got it. It's 0.4271. Yeah, I know. You can still do it. You can just write it. You use the lead if you push it, and then it will make stuff. You know what I mean? Sorry, I'm just like roasting my class here. Okay, so those are the x values, and hopefully you get those answers. We'll see you in the next video. Oh, no, we got to keep going. No, maybe we'll stop. No, we should stop and then start. That's what we got to do. Okay, we'll see you in the next video in like 5 seconds. Peace.